Hi there, and welcome to another episode of Mr. Ed Codes. This is part 2 of a previous episode where I made a meteor object that was followed by a shower of sparks. And in that video, there was a number of objects in the program, in the code. There was a background star, there were background stars, a moon, some mountains, and then the comet object that was actually being animated. So I had someone ask, can you just do the comet or the meteor object and the sparks just on its own without all the extra stuff, so it's easier to see what pertains to it exactly, and then maybe explain what is going on with the different variables. So that's what I'm going to do in this episode, and it might be a little bit long, so if you're typing along with me, you're going to love this because it's in detail. You're going to know what's going on at the end of this. If you like shorter videos, this probably isn't the one for you. But if you do watch along, I appreciate it, and let me know in the comments if this helps you out. Alright, so let's begin. I started with a new sketch. I've already set the canvas to the window width and the window height, and I just set an arbitrary amount for the background, just for now. We're going to change that later. Let's start with the global variables. There's only a few. We need one for our meteor object, which, to complicate things, I'm going to call it a comet, because I'll explain that. I think I explained it in the other episode, but see, comet is really easy for me to see. There's a vowel here, there's a vowel there, there's a consonant, there's another consonant, and they're all very distinct, except for the vowels kind of look alike. If I'm not looking at it closely, this E might look like an O, but I can handle that pretty easily. In meteor, I've got the E and O together here, I've got another E there. There's a chance for this to get transposed, for me to add an E there or switch things. So all kinds of stuff could go wrong with the word meteor. So I'm going to use comet when describing this object, but it's actually more of a meteor or a shooting star than it is a comet. God help us if a comet breaks through the atmosphere like that, because it's not going to go well. But this is just a meteor named a comet. I'm not sure if it even warranted all that explanation, but you got it anyway, so there you go. So what's happening here? We've got the comet variable to hold our object, the main parent object, which is this meteor. We are going to have sparks come off of that parent object, and that's going to be set to an array. So we have an array of sparks, and the number of those sparks in total is 120. So as it starts, it's going to release 1 or 2 sparks, and then a few more and a few more, and as it goes through its lifespan, it's going to release up to 120 sparks. The way the program runs, a new comet is born every however many seconds. So in this case, it's every 10 seconds a new comet is born. There is a problem with this, though. It takes a while for a comet to live out its life. So if you set the time to be born halfway along a comet's life, what will happen is that comet will immediately vanish from existence, and a new comet will be created every time it hits that fraction of a minute. So you want this value to be set high enough to allow the comet to live out its life, maybe a second or two longer, and then hit the clock, see, can we make a new comet, and then you make a new comet. So that's what that variable is for. And this value can occur in the program many times. You can use it again and again, so I made it a global variable. So before I move any further, I will say that when you adjust the number of sparks, fewer sparks will take away less mass from the comet, and that's what's making the comet live out its life. Is its mass is reducing every time it makes a spark. It gets a little bit smaller, and then once it gets its smallest size, it's dead, it's gone, and then that's the end of that comet. So if you have a lot of sparks that are able to come off of the comet, then it's going to take away its mass more quickly. And if there are fewer sparks to take away mass, then that comet's going to have a long life. What can happen is, as the comet lives out its life, it's going to eventually go out of bounds. It's going to go off the edge of the canvas. So then you have to handle the out of bounds condition. And what do you want to do? The intuitive thing to do would be just to create a new comet. Well, if you do that, again, it kills whatever sparks may still be on the screen. And if you want to just end that comet, the same problem. It gets rid of the sparks on the screen quickly, like all in one frame. And you want them to die down and live out their life. So you kind of have to strike a balance between having enough sparks where it looks neat, but not having so few that the comet goes out of bounds, has to go over to the left-hand side of the screen again and live out the rest of its life looking like a separate comet with the rest of the sparks coming off of it. So that can be problematic. So when you play around with the number of sparks, keep in mind that it is going to affect the lifespan of the meteor, or the comet in this case. So I just want to clear everything just to be sure everything's nice and clean to begin with, in case I'm doing anything with the backgrounds. I had an idea that whenever a spark flies off, there's a spire like a flare of light, and that would light up the sky a little bit, kind of like lightning. So I thought if I could keep track of the background and make a normal background when it's not sparking, and then make the background brighten a little bit when it does spark, that it would give this really neat effect. Well, I tried it out and I couldn't get it to work quite right. It needs some thought, so I'm just going to do that a different day. But I left this in here just in case later on I want to do something with the background. In that event, I need to have the background clear to begin with, because there might be an instance where draw is performed and it's not erasing the background like it's supposed to. So that's what that's for. It's not necessary to program the way that it is now, but it could come in handy later. So I'm just going to create a new instance of the Fireball function that I want to make here in a moment, and I'm going to set that equal to Comet. So now Comet possesses all the properties of a Fireball. Then I make a loop. That's going to be the length of the number of sparks, and that's going to create a new instance of all the sparks that I need for this program. I'm just going to do those in setup, create all the sparks that I need. And then the sparks are going to have a value that says whether they're alive or not. And then if they are alive, then we see them. But if they're not alive, then they pretty much don't exist. They're a part of the meteor, which will be true in a sense, because whenever they're reset, whenever a comet is born, all of those sparks are put on that meteor's location. So as the meteor's moving along, all of the sparks that will ever be born are moving along with it. And then as they're born, they're kind of released to die off of the back of the meteor. So we create all of our instances at one time. That's pretty much it for setup. Is easy. We're just creating an instance of our comet, creating instances of all of our sparks. I'm setting the background to a dark blue, like a night sky. Not completely black like space, but black like a moonlit sky, or something that you can kind of detect the atmosphere, but not quite. This will come in handy later on whenever I start creating the effects of like the flare, and how sometimes when sparks fly off of the asteroid, it'll get really bright, like welding sparks. So that's kind of what I was thinking about there. If I have the background a dark blue, then the viewer gets a sense that there's some atmosphere. And then when you do the flare, you just brighten that blue color, and it makes it look like the atmosphere around the spark is brightening up like a flashbulb. So I'm going to assign a scope variable s to the p5.js method for looking at the seconds of the time on your computer. So it's going to look at the seconds, and then it's going to make some decisions. So a little bit's going to happen inside this loop here. The condition, if it looks at the second and it divides it by our time check value, which in this case is 10, so it's going to divide s by 10. Well, if s is 10, then this condition is true. If s is 20, it's true. If it's 30, it's true, because it's comparing it to its integer value. So if s is 11 and you divide it by 10, well, it's going to be less than 0. It's going to be a fractional amount, so this isn't going to be true. So we're looking at every time there's an integer of 10 in our seconds, we're going to perform this operation here, and what it's doing is setting everything kind of new. Comets are born inside this condition. So to give birth to a comet, we're going to use the comet object name, and then we're going to use a function in that, a method in that object called new comet, and that's going to create all the variables for a new comet instance, or for a new comet, without creating a new instance of a comet. So in my sparks function that I'm going to create here, same thing, I have a method in it called newborn, so it's going to create newborn sparks, and the newborn sparks are set to the comet's position. So a new comet is created, it's given its random variables, and then it passes those variables to sparks when sparks are born in this loop here. So I create a loop, it's going through all of my sparks, it's setting all of those sparks condition, all of their properties to what a comet is. So this should be the end of my second condition, my seconds, and then this is the end of my 4 next conditions. So let's take out these spaces so it's a little easier to see. So that's all kind of one thing right here. It's looking at the seconds, it's checking to see if it's every 10 seconds, and if it is, it's time to make a new comet. So you can change time check to 15 or any section amount of 60 seconds. So once we've done that, we want to display the comet. So a comet is born, we want to look at that comet, so we need to move it, like update its conditions, because it's alive now, so it has physical conditions that need to be updated, and it may run out of bounds, so we want to check for that. And now we want to look and see, is it alive? Because it doesn't matter if it's alive or dead. If it's dead, then this is going to be changed by the condition that handles a dying comet, and if it's born, these are going to be changed to the conditions that handle a living comet. So there'll always be conditions relative to whatever state the comet is in, so we can always update and check the bounds of a comet, even if it's outside of the seconds that we're looking at. So once I have new values and I have a valid set of those, I'm going to check and see if a comet is alive, and if it is, then we're going to perform whatever it is that a comet does when it's alive. There will be a condition, a state that exists where a comet has mass, and if it has mass, then it can break apart, and that means it's flying across the sky. So if it's flying across the sky, we need to show that, and we also want to make sure that we're outside of the second, the 0 second, or the 10 second, or the 20 second, because that second is a long time. It could run 60 frames in that second, and in that time I'm going to see my comet jumping around all over the place as its random numbers are being chosen for its new birthplace. So it needs to be born, it needs new conditions, so those are randomly determined. So if I'm giving birth to it again and again in that 1 second time, it's flicking all over the place, it's just bouncing all over. So in order to keep that from being displayed, now that's still happening, but we can choose whether or not to display that activity. And since it's only happening in that second that the condition is true, then if we're not on that second, then we can go ahead and display the comet, and that's what we do here. Alright, so what is all of this doing? This right here is how alive our comet is. So if it has some mass, then it needs to be shown because it's moving across the screen. But when a comet is first born in that 1 second time, it's being born however many frames occur in that second. Because until it gets out of that second, that's when we want to display it. We don't want to display it while it's being born. We want to display it after it has definitively been born. And that only happens when we fall out of that second. So let's say it's second, it's like 10 seconds into our minute. So our condition is true. Let's create a new comet. Well, until that next second clicks over, that condition is true. So every frame it's going through and it's giving birth to a new comet. And when it gives birth to a new comet, it kills the old one. So we're seeing this comet be born, die, born, die, born, die, all over the place, wherever comets are born. It's being born all over the place there. So what we can do is look and see, are we on that second that a comet is being born? And if we are, then we're not going to look at a comet being born. We're going to give it some modesty. We're going to wait until after a comet is born, and then we're going to look at it fly across the screen. So that's what this does here. It checks to see if a comet is alive, and then it checks to see, have we moved off of that second, so we don't have to look at the nasty birthing of a meteorite. I could put an else in this here and say if this condition isn't true, and then whatever. But I'm kind of staying away from if else's if I can, because I've run into some problems with those. So I'm just sticking with what I know best, and that's just test it again. It's not a huge performance issue to do. Conditional statements do cost a lot of performance, but in this example it's not a big deal, and maybe that can be hammered out later on if it does become an issue. But right now it doesn't. It just seems easier to do it this way, or at least it's easier in terms of I don't have to worry about else conditions because those can get kind of convoluted, especially if you have something like this. You have a double condition here. So we have one condition joined by an and here, and then if I have an else, then I need to account for that and. I need to account for both of those, or else the else is going to throw a different true or false. Does that make sense? Probably not. Okay, let's move on to the next thing. We need a condition to handle if we're off of that time, off of that minute. If we are, then we can start doing all of our other stuff like making sparks, because the same thing's going to happen. If we're giving birth to a new comet, we're giving birth to new sparks, and if we're showing all of that being born, it's going to be, again and again and again, stuff's going to be flickering all over the screen. So we want to avoid that. What's all this for? So like I said, if we're off of that minute where everything's born, then we can go through the sparks. So we have to do a loop. It's an array. So we're going to loop through that array of sparks right there. And then we're going to create a scope variable here called yesSpark. And it's a random value between 0 and 1. That random value, if we look at it, and if it falls below 1%, 1% of the time when we look at this randomizer, this condition is going to be true, and if it is true, we're going to make a spark. So if you adjust this value, some things can happen. A higher chance of a spark being born means that the meteor is going to dump sparks faster. A real high number, or even kind of a high-low number, it'll give birth to the sparks almost instantaneously, just like bloomp, and it's just a big blob of sparks. So to keep that from happening, you want the percentage chance of a spark being thrown off to be pretty low. 1% is actually kind of high. You can go lower than that. So if you do go lower, then the sparks get spread out over time. If it is true, we're going to make a new spark. So in the spark function, we have this method we're going to make called makeNew, and in makeNew we have to give it some variables so that it knows what's going on. So we're going to send it the comet's position and the comet's velocity. and then it can use those to set the spark to the comet, so that it's actually a mini version of the comet, or a mini version of the meteor, except for things are going to happen to it differently than happens to the meteor. Like it's going to have a lifespan, and it's going to slow down and almost stop and then fade away. Once we know what sparks, it's going to print all of the sparks. Like I said, it's going to be kind of like on top of the meteor, or all the sparks. They're just all hanging out there. And when you update the sparks, you're going to show all of them. And then if any of those sparks need to change or move, this is where they're going to do that at. This is where they're going to be born, and then they start flying off the back. So the sparks that aren't born or aren't flying off the back are flying along with the comet. And we can display the sparks whenever we're off of that minute. Off of that second where they're being born. So that happens inside that loop. So now I think we are done with that part of it. So now we're ready to start doing the fireball function, and then the MiniFireball function that's going to handle making our spark. In this example, just to make things simple, the meteor flies from left to right. So it moves from the left-hand side of the screen to the right-hand side of the screen. So let's start the fireball. So we have a number of functions in our function here, some methods in there. We have update, we have bounds, we have render, and we have new comet. So those are some things that we need to think about when we're making our variables that start the instance of our fireball. So we're creating a brand new fireball instance and setup. What are the variables for that? There's our starting conditions when we create a new instance of a fireball and setup. This is what it gets. It's getting a position, and that position's X can be 45 pixels off of the left-hand side of the canvas to 40% of the width. So not quite halfway across the screen. So anywhere in that range, a comet can be born. Its height, or its Y, its vertical position, is going to be a percentage of height. So it can go from 10% to 5%. So 10% from the top of the screen to, I meant to say 50%, or halfway down the screen. So anywhere in that range, a comet can be born or appear on the screen. This allows for you to have some stuff at the bottom of the screen that would be in the foreground, but the comet's not going to pass over it. It's getting a velocity. That velocity, the X, is going to be a positive number, so it's moving from left to right, and its speed is going to be from 2 to, I'm going to make that a little bit faster, 2 to 4. So 2 to 4 pixels per frame. This meteor is going to be moving from left to right, and it's also got a chance to drop down a little bit as it moves. Well, actually a lot. It can have a pretty strong pitch here. So adjust this value, and that's going to adjust the pitch. That is it pointed down at a hard angle, or is it moving pretty much straight across the screen? That's what this variable is controlling. And then how fast it moves across the screen is these two numbers there. A minimum of 2 pixels, a maximum of 4. This velocity multiplier here is a constant, and it just brings up the magnitude of our velocity a certain amount. If you want to increase the velocity, just adjust these numbers here. You can increase the velocity by using this number, but you're increasing it on an order of magnitude. So if you want to do smaller, more refined adjustments, then just use this and leave that as a constant. This dot mass, its mass, or the number that it starts with, it's a high value from 9 to 18. And then a fractional amount is taken off every time a spark is born. So we're going to subtract from this value, and that's going to tell us whether or not a comet or a meteor is alive or not. So that's all of those values. Our first function is our easiest. It's the update. So our method in this function, this.update, it's just going to add to the position whatever our velocity is. So that's this is the method for handling vectors, is a .add and .multiply. So I'm going to use those. I understand those pretty good. Our next method will be a function to handle whether or not we're out of bounds. Okay, what's happening here? In this method, we're going to look at our comet, our meteor's x position and its y position. So the x position goes off the right-hand side of the screen or past the width, or if it goes below the screen or past the height, then we're going to just create a new vector as if it's born brand new. We're going to pick that random x position. We're going to pick the random y vector. Okay, so I think we're done with bounds, and I ask myself, am I sure about that? Yeah, I'm pretty sure about it. Let's explain a little bit, though, what happens when you adjust things. The next thing we're making is a method to handle how this is displayed, how a comet is displayed. In our render, we're just making a stroke that's going to be kind of a white color, and we're multiplying the mass times a random number. So when we display our meteor, its radius as it's being displayed is going to be related to its mass. And then overlapping that a little bit, I'm going to create a bigger point that looks like the atmosphere being illuminated. I talked about this a little bit previously. So I want that flash bulb effect. So I think that's what this is doing right here. It might not be. Hold on a second, let me look at something. You know what, I must have made that white. I thought it was yellow, but it must be white. So maybe that's not the flare. It could be, but I don't. You know, when I run this program, I'm just going to comment that out and see what happens, and then I'll find out what it is. Maybe I should have made a better note. Anyway, that's the comet. The bottom line of this method here is it generates what we would expect to see as the main body of the meteor, and then the sparks are going to come off of it. There's a lot happening to that in this program. I have lines that come off as like the spire, flare, and then the atmosphere being illuminated around whenever the sparks come off. So that's going to happen coming up here, I think, when I make a new comet, or when we make the fireballs, one or the other. The next method we do is the new comet function. Instead, I could have put all of this stuff in the draw and then had a condition that handled it. So whenever like the minute resets and a comet is born, just put all of this stuff in there. But it made draw look really messy. So I thought, just put it in its own method in the function and get it out of the draw so you can see what's happening in draw a lot easier. So that's what I did. So I just created a method in the comet function called this. And then whenever we make a new comet, we're just going to go back up here to our instance. Our instance variables, when we instantiate it, we're just going to copy that down to here. I think this should work. All right, so I've got a position. So when a new comet is born, it needs a position, it needs a velocity, it needs the velocity multiplied, and it needs a mass. I think that's all of the fireball function. Now we have to do the sparks. So this is the last part here, and I think this is probably the most involved. It's got a lot to it because there's a lot going on with these sparks. But just stick with this and I'll explain to you what's going on and we can get through this. Just like with the meteorite, it needs to have a position, a velocity, When we instantiate a new Fireball object, we're creating a vector that's equal to our meteorite. So that's what we do here. We set the vector position of the sparks to the comet's position x, the comet's position y. We set it to the comet's velocity, x and y, and we give it a lifespan. Its lifespan is going to run from 0 to 255. That's because we're tying the lifespan variable, we're going to tie it to how the color is displayed so that we can see the temperature in terms of color. And that's going to be the lifespan of the object. You know, it cools off, it dies, right? This is going to allow us to go from yellow to red. I don't want the sparks to all wink out at the same time, and I don't want them to wink out in perfect succession like the term from when they were created. So first in, first out. I don't want that to happen. What I wanted was for some of them to burn really fast, some of them to burn slow, so you get this variety of them twinkling out over time. So I do that right here with this burn rate value. When I subtract burn rate from lifespan, it's going to burn through its life faster or slower depending on that variable there. Our first method in this sparks function, this MiniFireball function, is going to be to make a new spark. Very first thing when we make a spark, we want to take away from the mass of the comet. That's what we do here. We're taking away from the parent object's mass. This isn't probably the best way to do this would be to create a particle object and then use that object whether it's a comet or a spark and then just pass variables back and forth. That's not what I do here. This is tied directly to a comet. So in order for sparks to work, it has to have a comet object. It has to have a separate object or it's not going to work. So that's kind of probably not the best way to do this because it makes it harder for this to be modular if you just wanted to use the sparks function. This right here just checks to see if it's died, if the comet has dropped below its minimum life, which is 1, and if it has, then we're just going to set that equal to 1, and then we'll know if a comet's mass is 1, then it's no longer alive, and then we can deal with that. If the comet's not alive, then we don't need to create sparks. But if it is alive, then we want sparks to happen. And when we're making new sparks, this is especially true. So we're making a new spark, or we're testing the new spark condition, and the comet is alive. So let's give a new spark the comet's X and Y position. And when I was going through this code again, this is true too. When I put a dot in here, that's true as well. When I take the dot out, it's also true because I passed the comet.pos.x position into the make new method right here, but I named it so close, I might as well just, I don't even know why I did that. What it ended up doing was confusing the crap out of me where I thought I forgot to add the syntax, the dot syntax here. But since it doesn't matter in this case because the variable name just happens to be convenient in this case. So if that confuses you, I'm sorry. I probably should have named those variables a little bit differently. And I could see, and this has been said before in a number of tutorials that I've watched, that you need to be careful how you name your variables that way because it can cause some problems, as it obviously did in this case. When I was going through here annotating it, I was like, did I forget my dot there? So I changed all the dots and nothing happened. I was like, how is that possible that if I leave the dot out, then it's theoretically not a actual variable. It doesn't exist. But since I named the mistake variable, so this is a mistake. It's a potential mistake. but it happens to work, incidentally. It was just so strange. It had me messed up for hours. Okay, so we got our comet's position. We've given it to our spark. We've given it its velocity, or at least its x velocity. It's going to keep the same x velocity. And then that gets diminished over time as we multiply it times 99%. I'll do that later here. The y position is what's really interesting here, because we're going to add to it a random amount. And that random amount could pitch the comet sparks upward, or it can pitch the sparks downward. And since I have it skewed toward the down position here, a propensity of the sparks are going to go down like they have some weight, and then a few of them might go up and away from that line. So it gives it some variety. And then the lifespan I set to 0 because it's newborn. This is where I get into the spire, the flare, whenever a spark is born and it creates like a burst of light when it's really hot. That's what I'm going to do here. That's a lot to put in there, but is it worth it? I don't know. You could tell me at the end if it's worth it or not. Just comment that out and look at the difference. I think it adds a really cool effect, like a little bit more realism. So what is it doing? So this variable here, it's checking, again, it's a percentage check using this scope variable here. I'm going to look at that variable, and if it falls below 25%, then I'm going to go ahead and do like a flicker, do this flash, this pulse of spire lines. So I'm setting the size of those lines, so they're not going to be, they're going to shrink over time. So if the comet's smaller, those lines are going to be smaller. If the comet's bigger, those lines are going to be longer. What are those lines? They're basically a backslash, a forward slash that makes an X, and then a vertical and a horizontal line. And it makes like a star, basically, an asterisk or a star. So that's what that does. Let me look here. I should be at the end of my make new. I am. So I've got all my brackets there. I'm always checking my brackets. So that's the end of the make new method of our MiniFireball function. Let's do this update, where we're going to update these. Oh, I think that's all the update function right there. I just typed it all in for you. What's it doing? Okay, let's look at that. So when we update our spark, we're going to take away from its lifespan. We're actually going to add to its lifespan. I subtract, I think, yeah, right here. So in the green part of our stroke, so if you have 255 here and 255 there, it creates yellow. And then as you subtract the green, it leaves more red. So you're going from yellow to red, basically. So I could, if I had lifespan go from 255 down to 0, like it's melting away, then I have to change all of these I have to make these calculations a little bit differently. This formula is a little bit different. So I did it that way just because it's easier to remember. We age 1 year old, 2 years old, 3 years old. So I just did that positive increment just so I could keep it in my head straight. It's like I'm adding to get older, and then I'm going to subtract its age from yellow to get red. And then this here just checks to make sure that I don't go out of bounds for my age. So once I've lived my life, then I'm going to set that lifespan to that, so I never go past 255. If I'm less than 255, then I'm alive. I'm doing what sparks do. So I need to have a velocity, and I need to have a position. And since sparks are slowing down, they're kind of stopping in the sky, I want to reduce its velocity each frame. So I'm going to multiply its velocity times a fraction. so that I'm getting a smaller and smaller amount of velocity each time I pass through. So our very last part here is what to do when we have a newborn spark. So just like we did with the Comet, I could have had the conditions to make a newborn spark in the draw function, but it makes it messy. So I just moved all that stuff into its own little method inside the MiniFireball function. That's what this is. That's all there is to the newborn. So when a newborn spark is created, we're going to set its position equal to the comet's position. We're going to set its velocity equal to the comet's velocity. We're going to give it a 0 lifespan, so it's just starting out, and we're going to give it a random burn rate so that it can burn through that lifespan. So if we did everything correctly, which I have a feeling there's something not typed correctly in here, so let's see how well I did. Let me switch this over to a wide window and we can see the results. I'm going to press play on this and we'll see what happens. So I've got a problem. Let's see what that is. Spire is not defined. So I have a typo here in my MiniFireball where I deal with my spire. It says it's in 120. Yes, there should not be an R there. Let me make sure I type the rest of those correctly. Yep. Alright, let's see what happens now. Well, that's not quite what we're looking for. So those lines are off somehow. I think maybe I typed in a fraction wrong. So let's go back here and look. Well, it took a second, a long second. I even put these periods, these dots back in here thinking maybe some force that I didn't quite understand wasn't accounting for it, but that wasn't it. It's actually right here. So in the this dot make new method of the MiniFireball function, go inside there, and when we draw these lines, this is the problem. I said that was the problem to begin with, somewhere in these line things. So it's the size of the spire. It's too big sometimes, and that's related to this random number. The reason why it's too big is that's supposed to be a plus, not a multiple. So what I wanted was for there to be a minimum spire size, and then multiply that minimum, or add to that minimum whatever the comet's mass is, and then it'll produce a nice spire. So let's see what that does. And there's more of the results I was expecting. So that's pretty much the full effect. I think I double checked most of the fireball function and the MiniFireball function are spot on. They're pretty close representations of the working code that I have here. If there's any difference, it might be a random number range is set from 2 to 3 instead of 2 to 4. Might be something like that, but it doesn't really affect the performance too much. Still pretty much the general output is the same. Alright, let's look at the output. Here at the end, I want to go through and adjust some of the variables so you can see the change in the effect. The first one I want to change is this number of sparks. If we reduce that, every time a spark is created, it's reducing some of the mass. Well, if you're not making a lot of sparks, then you're not reducing the mass as quickly. So the comet or the asteroid, whatever this meteor, is going to have a longer life. And you can see that here it'll go out of bounds and then be reborn somewhere in that range where it's born at. So that's what happens if you change the number of sparks. If you change the time check to lower, to a time lower than it takes for a comet to live, let's see what that looks like here. So it takes about 7 or 8 seconds for a comet to go through all of its animation, throw off its sparks, and those sparks fade away. So that takes a little bit of time. If we recreate if a comet is reborn before it's done living its life, then something weird's going to happen. Let's take a look and see. So what happens? It goes away before it's done, and then it's reborn. So we don't want that to happen. Just count out how long it takes for your device to produce the minimal amount of time it takes it to produce a meteor, and then just set your time check to a little bit higher than that. So for my PC, it takes about 7 or 8 seconds for one of these to be produced. So I want to set my time check to 10 seconds to make sure that it's lived out its life, and then we can go on to the next one. Adjusting the alpha for the background, that's kind of creates a cool effect. You get that ghosting, kind of the trails left behind. That's kind of a neat effect. Play around with that, it's fun. I leave it on 200. I think it's a nice place between erasing the background or refreshing the screen and producing enough of that blur. Let's go down to the yes sparks right here. So if we increase this number, then there's going to be a higher percentage chance that sparks are going to be born. So if that frequency increases, then the lifespan of our meteor is going to be affected. Its life is going to go by faster. So let's see what happens when we raise that percentage chance. You see here all the sparks just kind of dump at one time, and the comet goes away almost immediately, or the meteor goes away almost immediately. Let's lower that value to less than 1%. So now it's going to hang around for a while and get spread out pretty good. So you can see how that affects the comet's appearance. Let's go down here to the fireball and let's look at its y velocity. So this is the pitch, how angled down is the comet when it enters the atmosphere. If we increase this value, it's going to have a really strong angle, or at least a percentage chance of having a really strong angle. You can see here. This is going to be mostly straight across the screen. And then if we change these values here, it's going to be moving a lot faster. When it's born, 5 pixels per frame, a minimum, up to 9 pixels per frame as a maximum. Changing the position here, so it's starting out 45 pixels off the left hand side of the screen. That's the starting range, the minimum X value. The maximum X value, where it will start out, is 40% of the width. So if this is 50% of the width, it can start right about here. So anywhere in this range is where a meteor will start, and then it's going to move out of this range into the other side of the screen. And you can adjust that range by adjusting this number here. So I can make it closer to the edge here, just at 20%, or I can make it fill up almost the whole screen at 90%. So it can be born here and just fly right off the edge. Let's change the mass on this object here. So we have a possible range from a minimum of 9 to a maximum of 18. Let's change that to like 14 and 25, and let's see what happens. So the spire, the flare, is tied to the mass of the comet. So if you increase its mass, it's going to increase that flare size. So a larger massive meteor is going to take longer to disintegrate, and its flare is going to be brighter and more dramatic. Let's take that back down. I think that's pretty much most of the critical changes. Everything else is pretty much aesthetic, like how big are the spires, how big do you want the spires, how much of a chance do you want there to be spires or flashing. So you can play around with those and get it to be less or more dramatic, more frequent flaring, less frequent flaring. The flaring can be a larger size or a smaller size. So just adjusting these variables there. And whether it's stroke weight is at a minimum of 2 or a maximum of 4, and that's randomly determined each time it makes us fire. So you get a lot of flickering there. Okay, yeah, I think that's pretty much it. That's a look at the asteroid, the meteor or comet function method that I have. It's a neat animation. It's kind of a classic look, has kind of an 8-bit feel to it, but it's still pretty complicated with modern processing. You know, HTML5 canvas, you can do a lot of stuff. Let me know what you think. If you like this video, give me a thumbs up. If you have any questions or want to add anything to that, please leave that in a comment. I would love to hear that. And as always, until next time, take care.